Thermostat calls for heat. When the thermostat closes the white call for heat circuit, 24-volt control power from the red R terminal pulses to the white W terminal, and the furnace control board immediately begins the safety and ignition sequence to start combustion and circulate warm air. When the thermostat completes the W to R connection, first confirm you have steady 24-volt AC between R and W using a multimeter set to AC. Intermittent voltage means thermostat or wiring chatter and will stop proper ignition. The control board senses the call and runs a safety checklist. It checks flame rollout switches, pressure switch continuity, limit switches, and the condensate switch where applicable. If any safety device is open, the board locks out and logs a fault code, DO. Note that many modern boards blink diagnostic LEDs in a specific pattern, so learn your model's code chart. Next, the inducer motor runs to establish combustion airflow and the pressure switch must close. If the pressure switch does not close, check inducer vacuum tubing for pinches, blocked venting, or a failing inducer motor and replace or clear as needed. After a proven vent path, the control board opens the gas valve and issues ignition. On hot surface ignition systems, the element is powered and must reach glow temperature, whereas on intermittent pilot systems, the spark or pilot is established first. If ignition fails, inspect flame sensor and clean with fine emery cloth, and verify correct gas manifold pressure with a manometer. Once the flame is detected and proven for the required dwell time, the control board energizes the primary gas valve continuously and times a post-ignition warm-up delay before enabling the blower. This delay protects heat exchangers from stress and ensures efficient heat transfer. Finally, the blower relay engages at a speed determined by the fan control or proprietary curve on the board. If you hear short cycling or delayed blower operation, check fan limit set points, motor start capacitors, and the blower control jumper settings on the control board to match your duct system and heat load. For field troubleshooting, always document the exact LED fault code, sequence timing, and measured voltages so you can correlate intermittent faults to wiring or failing components rather than replacing parts blindly. One of the most common thermostat wiring mistakes is mislabeling or mixing up R, W, and common terminals, which causes no heat or continuous heat ISE. Fix by tracing the two-conductor cable back to the furnace, verifying solid 24-volt AC from the transformer to R, and confirming continuity to W when the stat calls. Another frequent issue is a dirty or corroded flame sensor causing ignition failures and repeated lockouts. Clean the rod with fine abrasive, reinstall with correct orientation, and verify microamps of flame signal per manufacturer specs. The third is incorrect fan blower timing, or speed settings that produce short cycling or overheated ducts, SU. Correct this by adjusting the fan on delay and fan off delay in the furnace settings, or swapping the fan speed jumper to the recommended tap for your blower and rebalancing supply and return registers. BigHomeProjects.com lists vetted HVAC contractors and detailed articles on thermostat wiring and furnace startup, so homeowners can compare local pros by reviews and certifications. The directory also helps contractors get work by publishing their profiles, service areas, and verified customer feedback to match qualified technicians with projects.